Good. I'm going to do two parts actually. I'm going to demonstrate Netrounds standalone, and to wrap up, I'm going to show closed loop assurance where NSO drives test and monitoring through assurance. A bit of intro first. So Netrounds, we're in the assurance space. Sometimes it's good when you try to educate the market if there's a hype wave at the same time. I mean, the automation was actually helped by SDN and NFV. So SDN and NFV, whatever happens, the good thing is that people started talking about automation. So that helped things move. In the assurance space, I'm afraid the hype is against reality. Because as soon as you start talking about assurance, everyone talks about telemetry, throw as much noise you have and throw some magic on top of that, and suddenly service assurance will appear. That's what you hear at conferences. And in my mind, that's a hype that is against reality. So we have a different point there. But I did a presentation in Madrid 3 weeks ago on service assurance. And there are sort of two ways of addressing when you're a service provider or an enterprise. So you have sort of a problem, and it might be service assurance. And either you're like the guys to the left there, or to the right, depending, the believer guys. So what you do then is that you read a little bit on the current hype trends. So it must be a bit of telemetry, it must be a bit of big data, must be a bit of machine learning and AI, and well, you don't read the books, that's boring, but you hear it, so it must be good, right? And you go to conferences, and you never bother reading a 600-page book to really educate yourself, but you have an opinion, where you have very strong opinions. So that's the way you sort of decide on what you're going to invest in to solve your assurance problem. Or you're a really, really boring guy. You start by asking yourself, what is the real problem? What is the real problem we have in assurance? It might be that we're provisioning services to customers with 3 different quality of service classes that we need to test and monitor. It might be that the customers are using IPTV and VoIP. And maybe we need to do a bit of research. How could I actually test and monitor different QoS classes? Maybe you need to read a couple of articles. Maybe you need to buy a book. And maybe you need to test and validate and reiterate. That's the scientific way. So that's how scientists works. So time for a poll. How do you decide on things when you pick solutions? Who are you? Leading question, right? I did this at a conference in Madrid coined Europe SDN NFV something. It was 50-50. It was a draw. Yeah, seriously, it was a draw. Okay, I think we can stop there to give them some time for the demo. But at Netrounds, we're scientists. We focus on solving the problem. And what's the problem? Well, if you look at service lifecycle, we talked about service lifecycle previously, and simplifying, the first thing, the service needs to be fast delivered. That's exactly what NSO does. Automates the delivery so the service is delivered fast. Second, as a customer, I would like the service to work. So you should test the service. And that's where Netrounds comes in place. So we're testing the services. Whatever services you provision with NSO, you should test it. As a programmer, you should have a test case. As a provisioning guy, you should test the service. And then once the service is up and running, you should actually monitor it in real time. And that's what we focus on. And we're doing it with scientific methods. Hardcore mathematics, looking at the data plane, doing mathematics. If you want, you can call linear regression AI, but linear regression is statistics. Read your mathematics books since the 70s. And we deliver three things. Deliver a test report, so when NSO has provisioned the service, you press the button over the API and you get a test report with all the network KPIs with scientific methods, mathematics, at the data plane, loss, jitter, delay, MOS, etc. Then, when the service is up and running, we monitor the services in real time per service instance. So not just like IPTV in general, but every individual service instance in the network. Updated every 30 seconds, the hardcore network KPIs. And there is no big data machine here. We look at the data plane, we send synthetic traffic, and we measure those, layer 1 to layer 7. And when you have a problem, we can automate the resolution. So, as I said, and what you're going to see in the demo now is that imagine you have this kind of network and you have the test agent somewhere. Let's start with the orange guy in the middle. So the test agent is our little scientist out there in the network, sends traffic to the network. And the interesting thing is that it reaches all the way through the network like unmanaged off-net part. So the traffic going out there to the edge, to the CPE, and then we're using built-in reflection. So reflection is a standard. So layer 2 and layer 3 reflection is supported by all vendors, Y7031 and TVAMP. That traffic gets reflected back, so we can measure the KPIs. We can reach out to content servers like SIP, telephony calls, IPTV, fetch those streams. And of course, we can talk agent to agent. So that's what we do. And again, it's at the data plane. We're sending synthetic traffic. So another benefit of that is there is no need to sort of implement support for specific MIB or parse specific syslog payloads. So what's the payload format of the telemetry API? There is no sort of integration effort because we work at the data plane. So whatever gets routed, that's what we do. And that's very different from IT-oriented, because as I said previously, the problem is that we're using IT-oriented assurance systems in networking. IT-oriented systems are, is this Exchange server okay? Is this Oracle database okay? That's more a point thing, and that's where most FM and PM system works. They don't see the network. So I will demonstrate now the Netrounds system, which basically is those small intelligent guys, 256 megs of RAM, sometimes 512 megs of RAM, one virtual CPU. You run them somewhere in the network. They can use reflection, they can do wireless, like Wi-Fi access points, layer 1 and LTE, and all the way up to layer 7, like video, SIP, and DNS calls. And then there's a Netrounds control center, which you're going to see now in the demo, where you have the web UI, and where you have the API towards NSO, where NSO drives the things. So this is the dashboard in Netrounds. Let me focus on that one. So as I said, it's basically two things. It's tests and ongoing monitoring. Let's first look at a test. So NSO provisioned maybe a VPN branch, but NSO also triggered an activation test. So what's an activation test then? It could look like this. So for this specific customer and this branch, what we tested is a couple of HTTP, DNS lookups, pings. We tested stateful TCP, so RFC 6349 is a standard on how to test that stateful TCP. Did some SIP calls, TCP, and like that, all the way up to IPTV. Then that gives you a report, which is fetched by NSO. It's just an URL, so NSO knows this is the test report for the service I just provisioned. There you get a proof. Yes, it did work. You get all the KPIs, and you can have the graphs as well if you like. So this is very important. After the commit from NSO, you get a PDF, it actually worked. Not just a ping. Okay, it's okay to start build now, not before you have this test report. Removes a lot of blame game. That was the testing piece. Once that is done, you can continue with active monitoring. And I'm saying active here, again, just repeating. We are always acting like an end user. So assurance systems, passive assurance systems, they will tell you, yes, the user is already angry. But with active monitoring, you can beforehand say, no, that site over there will not be able to run WebEx, because we are sending a few packets per second all the time to measure all the services. So we can tell beforehand if things will not work. So that's what you have here. Each of these are individual services. We can take this branch office, for example. So what you have in top here is the aggregated SLA. So this branch office, although the configuration was okay written by NSO, the SLA is still not okay. You see there are dips, the red things are, this is a second where the user is angry. And we can drill down, why is that site angry? That branch office. And here you get a fine-grained detail of network KPIs. So this is why we're working at the data plane and not the management plane. Whatever network KPIs you're interested in, we're measuring those. And it looks like it's a round-trip thing here. So there are round-trip measurements that are not okay, and you can zoom in. This is the latest 50 minutes. You can go over intervals, and you can have them in a table where you see what's the problem here. So it's really network savvy. So how do you actually define? I mean, the services you provision in NSO, they're different. There are different parameters and different SLAs. So when you design how to test and monitor, we have a designer environment. So for each of the tests and monitors, you as a network engineer, you design the test cases. I'll use that one instead. I think I have it. Yeah, this one is better. So what you see to the left there is the toolbox. So it's a toolbox of the available tests we can run in the network. During activation test, you actually flood. So that's intrusive, that's by purpose. During ongoing monitoring, it's not intrusive. So depending on what the customer has bought or what the users are using, this is the toolbox that you're interested in. When you go into one of them, you get sort of the detailed test cases to the right here. Let's look at an activation test for a bronze class. So imagine NSO provisions a site, and that customer did only pay for bronze. What we're testing here is then, first of all, the diff serve code points. That's okay. It's a very common problem that the diff serve code points along a path is changed. One device in the network actually changes the diff serve code point. So that's the first test. The second test sends 3 streams in parallel. So typically you have like a best effort in the business and the real time. And here we're sending streams in parallel to that site and measuring that. And then, well, let's select one of them here. Go on. What you do is that you specify, okay, so, oops, sorry, that was not my intention. There we go. You specify the threshold. So what's the threshold for loss? What's the threshold for delay that is acceptable? I mean, this is no magic. This is network service assurance, right? And this test builder, we can continue here. Let's go back to that specific. Let's say, well, that customer is actually also using other services. So it's very easy here. You just add a step. You might want to add a little bit of DNS testing. You might want to add a little bit of UDP testing. And at the end, you would like to add a bit of IPTV testing. And you can move these guys around. And you can add parallel there. You can copy. So very easy. Then you save it. And then you have a template to drive when you test the things. That was the quickie on Netrounds standalone. The last piece I will do here, so what I did now is that you can run it as a standalone customer. You can sort of trigger things from the UI, which is where most customers start. And I strongly recommend that. Start with NSO, automate your services in parallel or after. Run Netrounds standalone to design the template, start getting acquainted then you tie them together. Because the beauty is when you tie all these together so that whenever you provision, you also test and monitor automatically. So what I'm going to show now is the following. So, as I said, Netrounds Control Center, that's the central controller. Then you have test agents out there in the network, but there's a netconf yang API to the control center. So NSO can trigger tests, can get the test results, NSO can start the active monitoring, NSO can get the SLA status. So what I will show in the demo here is NSO provisions a service, and then NSO triggers activation testing. That is okay. NSO goes over to active monitoring. Then we have a problem in the network, and then we move over to healing and troubleshooting. Now in this demo, it's a tight loop between NSO and Netrounds. That's in place, that integration is in place. Of course, at specific use cases, I mean, the trouble ticketing system could be involved here in the loop. iTential could be on the top of this. I don't have an opinion there. I'm just showing here that things can be automated and build assurance into the provisioning. So that's what I'm going to demonstrate now. And for the first time in my history, I will break Stefan Vallin's presentation rule number 1, never show videos when you talk, but I will. Because this is a real network scenario, we have a network, we want to do network impairments, I want to have some loss over there, and we also have the Vasa Museum, so just to make this run really quick, I've recorded the demo for 4 minutes, so I'm going to talk through a video. Boring, I know, I usually don't, but I will do here. This is the famous NSO demo. All of you have probably seen this demo. We've extended it to include Netrounds here. So what we're going to do is that we're going to provision a new site to the right here. So we will add that CE to the site, and we enter the parameters for the service. And here's a very interesting thing. In that classical demo, we're giving a QoS policy, silver, bronze, or gold, which is different QoS classes in the network. How do you know that actually that works? Well, what's going to happen here, so look down here, remember that template I did show you. So depending on the QoS class you pick, NSO will pick a corresponding template in Netrounds to test that it actually works. So if I select another QoS class, it will select another template. So I'm committing the service. And now, down here to the right, you see 2 new buttons. This should be automated, but we're sort of doing this for the demo here. So we can start the activation test, and then we can start the monitoring. And further down here, we have the previous site. It already passed the test, and the SLA is up and running. But now we will test the new site. So NSO will make a call to Netrounds. Please test that new service according to that definition. Moving over here, now we're in the Netrounds UI. So that API call created that test. The test has been running, and now also NSO started monitoring. So we have test passed, active monitoring ongoing for that branch. We will now show a demonstration scenario, and we've talked a lot about out-of-band configurations in this conference, and we also said that over 50% of the problems in networks is out-of-band configs, non-optimal configs. So what's going to happen now is that a network engineer goes into CE2 and changes a shaper. Very common thing. Alarm systems will be blind, because it's not a fault, it's another config. So that will happen, but since we have active monitoring ongoing here, what you're going to see now is that we have an SLA violated up there, because we detect that, because we're sending traffic. NSO now starts an automated process. So what NSO does is it stops the monitoring because it's not of use. It will check if the devices are in sync. it will redeploy the service and test again, because now we've redeployed the service, we should test that it works, and then start monitoring. So that's what's going to happen now. So this is NSO CLI. So what happened here, I need to say here, Netrounds sends SLA alarms northbound, netconf, or as an MP trap. So there was a netconf notification going back to NSO. NSO got that we have a problem on that specific service. That triggers a action called troubleshooting. And what you see here in the NSO CLI is the output from an action in NSO. Troubleshoot that service automatically for me. Stops the monitor, checking devices, syncing, redeploying. All this is fully automatic, driven by NSO, making calls to Netrounds. And what will happen now is that we will run the, it's still redeploying, yes. And now, after that redeploy, we're running the activation test, waiting for it to be completed. And this is how it looks. So you see the arrow here, the blue arrow means this test is running. So now we're in the Netrounds UI. We can see that that test is running after the redeploy of NSO. We can see what it actually does. It's checking reachability, it's checking throughput, and it's checking the path MTU. Yes, it works. Customer is happy. We're auto-healing. So this is a full loop fixing that problem. Non-optimal config, SLA violation. Now it's a more tricky thing. Now I have 10% loss in a specific QoS class in a specific section in the network. Can be an out of a connection that you're not reached. Oh, sorry. Let me go back there. Here. So there's a loss there. It could be sort of a load issue on that part. It can be an off-net connection. So there's a problem in that specific section. How can NSO help in this case? Let me do a bit of fast forward here. There we go. First of all, again, since we have active monitoring, we get an SLA alarm up there on the Volvo branch. It will send a notification to NSO. NSO will stop the service. Try healing. If we're lucky, we can auto-heal by just redeploying, but it won't this time. So then we start another sequence. And what's the difference between a troubleshooting sequence and an activation test? Well, the thing is that when you do an activation test, it's a black box. You test from an end user perspective, do I get the service I need? When we're doing automated troubleshooting, that's a white box, because then you want to sectionalize. Where in the network do I have the problem? So then you run tests per section to find it's on that spot, it's that specific KPI. So it's a different template. It's the same mechanism, it's just a different template. So here we see again, NSO tried healing, but the devices are in sync. So it was not a config problem. We do run an activation test because that's user information that we will use later on in troubleshooting. So NSO triggered this case, and certainly we can confirm the throughput doesn't work. We don't get the required throughput. Now NSO started the troubleshooting, and this is a really interesting piece. This is a different template, and the magic, I would say, is in the second segment there, because you want to know where in the network do I have the problem. And what we're using there is reflection. The TVAMP is a standardized reflection protocol at layer 3. So here we're running tests hop by hop by hop to see, oh, the problem is over there. So that's that thing. So throughput, not good. Now we're running these different segments. And what we can see is that it's between the headquarter and the CE2, we have a huge loss. So by running reflection, we can see exactly where it is, and we can see where we have loss. So at this point, what can you do? Well, here is where Netrounds stops. So we're going to generate the report saying, at that point in the network, you have a high loss. that's a report probably fed to ServiceNow or iTential, and here's a network engineer. At this point, you do manual work. How can we fix it? Because it's very hard to do the last piece of magic here, but fully automatically, we've pinpointed exactly where in the network the problem is, at which layer the problem is. So that's fed, and once that is fixed, maybe the ticket in ServiceNow, when you close the ticket, that makes an API call back to Netrounds to run an activation test again, because we should test that it works. Closing the ticket is not enough. Test that it works. So that's the final piece. So that was the end. And repeating what Christian said this morning, perform an activation test and not just a ping. Once that is passed, make sure you start active monitoring as part of the provisioning process. Don't just sort of hope it happens. That was the quickie demo.
Okay, guys, time for questions.
Yeah. Maybe Mats, you can come down here. I need my expert ibland sometimes. I'm bringing my colleague Mats down here to answer tricky questions.
My question is about troubleshooting,
yeah.
step, whatever.
Yeah.
Do you actually run Traceroute
yeah.
to figure out what's the next stop, and then just go step by step?
Yes, so that's a very common. If you look in the, let's go here. So one of the test blocks, I mean, where is the Traceroute block? Do you remember, Mats? Yeah, there it is, yes. So one of the things you can automate, because the thing here is that you can automate, and Traceroute is one of the blocks you can automate. Yeah, so Traceroute is there as a tool, as part of one of the tools you can use.
Okay, yeah, just wasn't sure because if that you have to do the, design your test in a way so that it has a couple of steps, or just
and Traceroute is a very common piece you build into the troubleshooting sequence, because that's what you do as a network engineer. So of course you can automate it here. Yeah.
Okay, thank you.
So I have a question about the test agent. So how do you deploy the test agent dynamically on the service? So for service 1, we have VLAN 1 on one side and VLAN 2 on the other side. Service 2 have 3 and 4 and so on and so forth. So how do you deploy? In this demo, I didn't get that piece.
So there are several answers to that. And the first simple answer, and the way most customers start, is statically deployed central test agents. One test agent can handle 8,000 parallel streams. And then you use reflection. So you just have statically central deployed test agents, and they use reflection to the existing infrastructure. That's the easiest way to get started. Then you can only test to layer 3, because you don't have a test agent out there. Imagine you have like NSO, and you have this function pack called Enterprise NFV or vBranch or something. Looking to the Cisco people here. If you have compute out there, and then, of course, NSO deploys the test agent, because it's just a VNF. So the test agent requires 512 megs of RAM, one virtual CPU, can run as a container, as a VM on bare metal, and it's validated with NSO and ESC. So NSO, as part of the provisioning process, it can actually also dynamically deploy the test agent as part of the service chain or on the site. Some customers just drop them on the compute space available. So several options there.
Thanks, Stefan. Further question, guys?
Do you offer HTTP transaction testing as part HTTP transaction testing as part of your suite?
Well, transaction testing. So we're very careful here. We are focusing on the network up to layer 7, and we have an HTTP test component here. So you enter the URL, you specify the sort of response, etc. But we're not an application. I mean, App Dynamics, which Cisco acquired to do stress testing like and do HTTP load tests, that's not us. That's App Dynamics.
Okay, so in terms of, say, logging into websites, checking the transaction between the time,
Yeah.
It's not supported.
Well, yes. So let me show you the HTTP thing here. So this is the HTTP component. So you can say, so for how long, how many, to what with the endpoints, what's the URL, time between requests, and the response you should get back, and timeouts, that you can do. But it's certainly not, if you want to stress test your web application, no. But if, I mean, as I did show in the activation test, it's very common, can I reach the intranet, can I reach that kind of system? So to a certain level, yes.
Okay. Do you also, as a company, offer any sort of cloud services?
Yes.
So testing outside in?
Yeah, so actually where our company started was in the enterprise market. So the control center I'm showing here, all our enterprise customers, we have about 200 enterprise customers, they are using the control center running in Amazon. So it's a multi-tenant control center. So as that kind of customer, you just install the test agents, they do a call home, and then you get it hosted. And then back to your question, so do we have test agents distributed at random places over the world? No.
Okay. No, thank you.
Thanks for the question. Any further question, guys?
But on the other hand, the test agents is validated on Amazon and yeah, the Amazon. We have an Amazon AMI, yeah.
Okay, so you're still going to have the opportunity to ask further questions at Stefan and the team during the dinner. So I think we are close to wrapping up, Niklas.
Yes.
So I have one closure slide, and then I'm going to hand it over to Niklas, who is going to do the final saying and giving you directions for the dinner tonight.
Thank you.
Thanks, Stefan.